This video we'll be looking at the November 2014 grade 12 paper. The following diagram below shows the preparation of an ester using prop 1-in as a starting reagent. P, Q, R, and S represent different organic reactions. So we don't look at the questions when we are doing organic chemistry. We first look at the information that is provided to us and then try to simplify it as much as possible. Okay. We are given prop 1-in and then it undergoes reaction P to form propane. Okay. The only way for that to happen, the only way to move from an alkene to propane is if the reaction undergoes hydrogenation. So you are going to add hydrogens to the double bond of your alkene to produce what? An alkane. Prop 1-in will have a structural formulae that looks like this. Okay, so we are saying at carbon number 1 we have a double bond. Prop means we have 3 carbon atoms, which is 1, 2, 3, 2, 3. And then at carbon number 1, we must have what? A double bond. Okay. Okay, so this, it undergoes reaction P to produce what? Propane. We have an alkane with 3 carbon atoms. Okay. And then we are adding what? Hydrogen. The hydrogens that are added will be attached to those 2 carbon atoms because that red bond is going to break, and then it is going to allow for the 2 hydrogens to be added. And that is the structural formulae of propane. So this reaction here is called hydrogenation. Or you can say it is an addition reaction because we are adding what? The hydrogen to the carbon atoms. So you can say it is an addition reaction. Okay. And then from propane, we are forming a haloalkane through reaction Q. They are providing us with chlorine, and then we are forming a haloalkane. We don't know the type of structural formulae that the haloalkane will take, so for now we'll just skip. And then from the haloalkane, we are forming an alcohol. And then the structural formulae is of prop 1-ol. It is going to be an alcohol with 3 carbon atoms, and then 1-ol means that the OH group is attached to the terminal carbon. And then now I'm just going to go back to that haloalkane. Okay, I have a haloalkane there, right? And then from that haloalkane, I am producing what? An alcohol. The only way to move from a haloalkane to an alcohol is through what? A hydrolysis reaction. So for the hydrolysis of haloalkanes to produce the corresponding alcohol, we need sodium hydroxide that is diluted and then plus mild heat. Okay. And then hydrolysis is a substitution reaction So we just have to substitute what the halogen in the haloalkane to produce what the corresponding alcohol. So I'm going to have a haloalkane with 3 carbon atoms, and then the chlorine must be attached at the terminal carbon. And I know this because I know that hydrolysis is a substitution reaction. The only way for me to have an OH attached at the terminal carbon is if my chlorine was attached at the terminal carbon. Okay. Okay. And then now we are moving from an alcohol to produce what? An ester. So this type of reaction is called esterification. And this only happens when you take an alcohol and then react it with a carboxylic acid. So we need to have a carboxylic acid through reaction S in order to produce an ester. Okay, now our diagram is complete. We can tackle the questions. 4.1. Write down the type of reaction represented by Q. We said that we are moving from an alkane to produce what's the corresponding haloalkane. Okay, so you can see that here we have substituted that hydrogen for the chlorine. So that is a substitution reaction. Or you can say it is a chlorination reaction because you are replacing the hydrogen with what? With the chlorine. So chlorination. Or you can say it is halogenation because chlorine is a halogen. Halogenation. That's 4.1.1. 4.1.2, the type of reaction represented by R. We are moving from a haloalkane to an alcohol, so that is hydrolysis. Okay, and then 4.2, 4.2.1. For reaction P, write down the type of addition reaction. For P, of course it is an addition reaction because we are adding hydrogens to those 2 carbon atoms. And then the type of addition reaction is a hydrogenation reaction. And then 4.2.2. They want us to write down the balanced equation using structural formulae. So we have prop 1 in, and then we are reacting that with hydrogen to produce the corresponding what? Alkane. Then 4.3. Write down the structural formulae of the haloalkane formed in reaction Q. We said this is going to look like that. Chlorine, then 4.4. In reaction S, prop 1-ol reacts with ethanoic acid to form the ester. We have prop 1-ol and then they are telling us that it reacts with ethanoic acid. Eth means 2 carbon atoms, and then ethanoic acid, we're just going to add the carbonyl group together with a hydroxyl group. That is the structural formulae of ethanoic acid. And then it produces the corresponding ester. Okay. So during esterification, when we take an alcohol and then react it with carboxylic acid, we produce the corresponding ester plus water. So it means that when these two react, we need to eliminate water and then also form an ester. And the way that we do this, we are going to remove that OH and that hydrogen. So when these two combine, they are going to form the water. Okay. So what is left now? If we remove that, we are left with those two. And then we are just going to join the two. I'm going to start with the alcohol. So this is going to be 1, 2, 3. And then we are going to join this carbon to that oxygen. Right? And then we also have the carbon at the end. So that is going to be our corresponding what? Ester. Let's answer the questions. For this reaction, write down there 4.4.1 the name of the reaction that takes place. That is esterification. 4.4.2 the formula or name of the catalyst needed. So you remember we said that we also have water there. It means that we need to use a catalyst that is a very strong dehydrating agent, and that happens to be sulfuric acid. 4.4.3 the structural formulae of the ester that is formed. So that is the ester there. It is an alcohol with 3 carbon atoms, OCO. Then we have that. That is the ester that is formed. 4.4.4 the IUPAC name of the ester formed. So the way that we do this, we're just going to divide that ester into 2. You remember this part, it comes from the alcohol, and then this other side comes from a carboxylic acid. So the way that we name this, how many carbon atoms do we have? We have 3. So that is going to be prop. So prop means 3, that is the prefix. So you say prop, and then you just add the YL. That's the part of the alcohol. So it is propyl. And then we have 2 carbon atoms for the carboxylic acid. So it is going to be eth. So it is propyl ethanoate. Okay. 4.5. The prop 1-ol formed in reaction R can be converted to prop 1-ene. Write down the formula on the name of the inorganic reagent that is needed. So we are moving from an alcohol into an alkene. Okay, that means that we need to remove the OH. Okay, let me just write it down. We have an OH there. And then we are moving from an alcohol into an alkene. So what have we done? We have removed the OH, and then we've also removed a hydrogen. So we have removed water. And then we said that a good dehydrating agent would be what? Sulfuric acid. So that is the inorganic reagent you need. You can also use